In this video, we're going to cover 3 different types of solutions that we did not use all the time in Gen Chem 1. What do I mean by all the time? Well, it seemed like any time we were going to do solutions, it was either like milligrams per mil, milligrams per liter, or molarity. Those are very common. And so sometimes I find students forget these other things exist. So what are these other things? We're going to do 3 types in this video. We're going to start out with molality, not molarity, molality. It has a little m. Okay, don't get that confused with mass. This little m is molality. Then we're going to do mass percent, and then we're going to do mole fraction. So we're going to do each of those, and we're going to do them with sodium hydroxide being our analyte, our thing that we're looking at, which has a molecular weight equal to 39.98 grams per mole. Now that we know that, let's go ahead and do each of these problems. The first problem states, if I make a solution by adding 83 grams of sodium hydroxide to 750 milliliters of water, what is the molality of sodium hydroxide in this solution, assuming the density of water is 1 gram per milliliter? The first thing you need to do is remind yourself of what is molality. Molality equals moles of solute over kilograms of solution, or mass over the mass of your solvent in kilograms. So how do we do this? Moles of solute. So if we're going to start out with 83 grams of sodium hydroxide, and we're going to need to convert that into moles, okay? How much solvent goes on the bottom then? How much solvent did we state? We said that we have 750 milliliters of water. So now this is already kind of set up in the right format. We have solute on top, the thing that goes into the solvent on the bottom. Now remember, there's a big difference between solvent and solution. Make sure you're doing the right one. Solvent is just the thing that does the dissolving. Solution is everything in the solution. And so solvent is on the bottom. Now we just need to convert. So 1 milliliter of water is approximately equal to 1 gram. That was just the assumed simplified density. The density of water does change based on temperature, obviously, so we could change that based on the temperature, but for this one we assumed it was 1. Then we know that we need to get this into kilograms. How do we do that? 1,000 grams and 1 kilogram. So now we've got kilograms of water on the bottom. And all we got to do now is convert from grams to moles. So 39.98 grams per 1 mole of sodium hydroxide. Type all of that into your calculator, and what do we get? We end up with a solution that is 2.8 molal sodium hydroxide. So what is our molality of sodium hydroxide? It's 2.8 m. Obviously rounding to 2 sig figs because of our 2 sig figs and 83 grams. Let's do another thing. So next thing we're going to look at is mass percent. So percent mass is equal to grams of my solute. Well, really it's mass over my solute, and that can be in grams, over mass of my solution, expressed as a percent. And so how do we do this? Mass of solute goes on top, which we've already done, so we know it's 83 grams of sodium hydroxide, over my mass of my solution. So what do I need to do here? Is it acceptable just to put 750 milliliters on the bottom? No, that's my solvent. I need 750 milliliters converted to grams. So in that case, that's 750 grams of H2O plus my grams of sodium hydroxide, because it's solution on bottom. So we're going to put all of that in our calculator and then multiply the whole thing by 100 with units of percent to give us a percentage. So I guess I should put that up here in the formula. We get a final answer of 9.964%, which is approximately equal to 10 with a decimal percent. For our next example, we're going to look at mole fraction. And so what is the mole fraction of sodium hydroxide in our solution? This is just a third way of expressing concentration. Now remember, mole fraction is just simply part over whole. Part what? part. How many moles do we have of the substance we're interested in, divided by the moles of the total, how many moles total you have in your solution. So in order to start, we're going to want to convert all of our grams into moles. And so we've got grams of our solution, grams of the whole. So we're starting out with 83 grams of sodium hydroxide. So we're going to convert our 83 grams of sodium hydroxide into moles using our molar mass, which is 39.98 grams per 1 mole of sodium hydroxide. So that equals 2.076 moles of sodium hydroxide. Now we need to convert our 750 grams, because we had milliliters, 1 gram per milliliter, so now we have grams of water. And so we convert that using the molecular weight of water. So we divide that by 750 divided by 18, which is the molecular weight, and we end up with 41.644 moles of water. So now remember, fraction, our mole fraction, it has this symbol. So mole fraction of what? Sodium hydroxide equals the moles of the part over the moles total, which is our solution. So what is making up our solution? We've got both the moles of sodium hydroxide and the moles of water for our solution. So our mole fraction equals moles of sodium hydroxide over my moles total. So our moles of sodium hydroxide plus our moles of our water. And we get a final mole fraction of 0.047. Remember, if you're asked for a percent mole fraction, you would just turn that into a percent by moving that decimal over 2. So my percent mole fraction is 4.7%. But remember, this is how you would do mole fraction. Get everything into moles, part over total, and then divide. And that's our mole fraction.